Greetings, RC model geeks, and here we are in the shed yet again for part 14 of the Sarik Hobbies de Havilland, Canada Chipmunk build. Right, well, this morning I just thought I would trial run the ribs on the wing. Just clipped in a couple of the spars, blah blah blah, see how it all went. Beautiful, no problems at all. So that is good. And I was going to look at the bell crank for the ailerons and the positioning of that, etc, etc. As you know, it's push rod driven, blah blah blah. Now this bell crank system, I've been torn over this. I wanted to do it because that's how it was originally, but I know there's a lot of people out there that'll want to put servos in there instead of the bell cranks and everything else. But I wanted to do a bell crank because I wanted to show you how it was done. So, I wanted to find a linear servo, which makes it much easier to drive the pushrod system. You don't get the movement up and down of the pushrod with a linear system. It's just backwards and forwards. I can't find one. Nobody makes them anymore. So anyway, in the meantime, those good guys at Flight Comp and Ali, I think it's Ali rather than Ali, sent me a food package. It's a survival rations here, and in this package is a load of small servos by Bluebird, and also a pack of ball links and solder on things and stuff like that. Brilliant. We'll put that to one side because it's the servos I want to talk about. Now, I don't like putting servos in wings if I can help it, because you're just putting weight out there and the whole thing acts like a bloody like a flywheel. You know, if you've got weight a long way out on the wing, it can cause issues now and again. But I looked through this package of servos to see what there was. Now these Bluebird servos are bloody animals, let me tell you. And what I'm thinking, I'm going to go half and half because, like I said, I want to do the pushrod thing still. So what I'm going to do, I'm going to use 2 of these Bluebird servos for the ailerons, and then I will do bell cranks for the flaps. So that gives me that sort of, you know, option of showing you how the bell crank thing works. And then also the simplicity of the servos on the ailerons. Right, so I've opened up one of these Bluebird servos. Now these things are small. Look at the size of that. Alright, but look at the size of the mounting for the output arm. It's massive compared to the servo. So then we go and read the specs on this little servo, this little dinky one here. And it says it'll work on high voltage. These will run up to 8.4 volts, these servos. And the specs say if you run it at 3.7 volts, in other words, or a straight 1S, this will put out 2.2 kilograms of torque. 2.2 kilograms. if you run it at 8.4 volts, it puts out 5.3 kilograms of torque. It's mental. Doesn't really want to focus, does it? There we go. These things are mental. There's the specs on them, if you can read that. So, do you know what? I'm going to use these little brutes for the ailerons. I mean, they'll get lost in here, mind you. Let me just drop one in. And we'll drop him in there. And I'll bring the camera over. I mean, he's lost in there. He's smaller than the bell crank. Yeah, and I mean, this thing has got all the torque we require and a lot more. So that is going in there, and then the, like I said, the flaps will be on the bell crank. So yeah, that's what we're going to do. Now let's have a look at some of these other servos they supplied. I was going to go actually with these ones first of all. They're a little bit bigger, and the specs on those is 1.9 kilograms at 4.8 or 2.3 at 6 volt. So they would have had the grunt for those little ailerons as well. As you can see, they're aluminium heat sinked, all metal gears, coreless, digital, dual ball bearings, and I mean that's a beauty as well. Which one have I opened? That one. There you go, look at that. These things are just, look at the size of that shaft, it's massive. Yeah, you get some nice little instructions with it. And a good thing about this, I don't know if you notice, you buy a lot of servos from Hobby King, for example, and they've got a lot of travel. And sometimes that ain't useful. Yeah, you know, you almost get 180 degrees of travel on a lot of the Hobby King servos. And, you know, when you get round here, you can't use the bloody thing anyway, you know. Whereas these ones, they've got slightly less. They've only got 120 degrees total movement. But all that movement is usable. So that is good. 250 hertz frequency. It's got to be good, isn't it? So yes, that was another one. They also supplied some, look at these little babies. Now, if you thought the other ones were small, these are just minuscule. I can get them out of the packet. The hardest thing is getting them out of the packet. There you go. I mean, that is small. Metal geared as well in that size. I mean, it's crazy. Let's compare it to this little one here. I mean, it's funny. So small. Anyway, now this little dinky one. Let's have a look at the spec on that. That does 1 kilo of thrust at 6 volts, or 0.8 of a kilo of, sorry, torque. 0.8 at 4.8 volts. All metal geared, coreless motor. I mean, these are crazy. And it's digital. Hey, look at that. The engineering in that is just stunning. It's really amazing. It's like a little Swiss watch in there. All metal gears. Let's get the old vernier out and have a measure of the size. That servo is 7mm wide. I think. Let's drop that down. Zero it. Make sure we're accurate here. 7.8 millimeters wide, and the body size 18. And what's the height of it? 16. These things are dinky. Great for that would be great for your little glider. It'd probably be like 10 times the price of your little glider, but it'd be great for your little glider. That. So yeah, there's a nice little choice of servos here, and there's also this type as well. I haven't had a look at the specs on this one. What's this one? 1.5 kilograms of thrust at 4.8 volts and 1.9 kilograms at 6 volts. Let's have a look at that one, shall we? They all come with like accessory packs there. That's a nice looking servo as well. Digital tail lock, so this is going to be quite a fast servo. That'd be for a tail rotor on a heli. Let's have a look at the specs on that. Doesn't say what they're made out of. It is plastic, the gears on that one, but it's probably some high strength plastic. Yeah. M90? I don't know. Is that the material? Yeah, so we've got a nice selection of servos there. Thanks to Arlie at Flight Comp in the States. Now they're big into gliders. That is their main thing. So yeah, they've got a YouTube channel as well. Go and check out their Flight Comp channel, and go and check out their website as well. I'll put links in the description to that. They've been great supporters of RC Model Geeks, and yeah, well, what can I say? Give them a good old thumbs up and stuff, because you know, without people like Flight Comp and Arlie, we wouldn't be doing this. I keep saying it, but the generosity of people is what keeps this going. It allows you to watch the videos, enjoy them, criticise, whatever. So that is what we're going to do. We are going to use those gears, not those gears, those servos there, that one, yeah, and we're going to put that in the wing. I think that is what we're going to do. Anyway, so I've got to drill some holes in this, in some of these ribs for the cabling. Oh, I've also received my lighting kit, and there it is. That is the lighting kit from eBay, with all the LED lights and the controller. There's the controller. I don't know whether that'll show up. It's there. All the sockets on it. You plug that into an aux channel and you can control the lights from that. It comes with a load of LEDs. We might change some of these LEDs out for different ones. So we'll see how that goes. So yeah, like I said, got to put some holes in this lot. We need a hole for the servo lead now, and we need a hole for the lights. But yeah, this all slotted together quite nice when I tried it here. Yeah, I mean, what more can I say? It's just going together beautifully. So I'm going to carry on. I'm going to take this all apart now, drill some holes in it, and then probably start gluing it together. Right, God, sometimes things just take a long time. Once I looked at the mounting of a servo in the aileron position instead of a push rod, I had to work out how I was going to mount it, and I wanted to do it, you know, as light as possible. I didn't want a massive plate, etc, etc. So, and the other thing I don't want on this plane is a bloody screw plate underneath the wing. I want to keep it as clean as possible. I want to make it look as it should do. You know, you wouldn't have had a plate with 4 big screws in the bottom of it. So, the servo install for the aileron has got to be as reliable as possible, because it's going to be covered over, basically, and if you need to get it out, you've got to cut the covering. But you still need to be able to get it out once you do cut the covering, so the plate that the servo is mounted on needs to be removable from the wing. And so I made this, which is a plate in the rib. It's cut into the rib there, and I used a bit of spruce cut in there and created a slot with a couple of end stops, so that the plate here that the servo is mounted on slots in. That's one side of a servo fixing done. Then with the next rib, I put a ply plate on there that's going to sit like that. So from underneath the wing there'll be a screw here. This will be covered over, of course, obviously, but there'll be a screw here, or 2 screws that go up into that plate and hold this plate on. That's it, simple. So if I ever do need to remove this servo, it ain't too much of a pain. I also mounted a couple of ply blocks to mount the servo onto this plate. Now, because I wanted to make this as failure proof as possible, I didn't just glue it to this plate, because there is a chance that those could break. They're screwed through as well. So we've got a screw there and a screw there that screws into that block, and then the 2 screws for each side of the servo that hold the servo onto the plate. So hopefully that's never going to break. So that's all good. Then, of course, I had to make all the holes in the ribs to take the servo cable. So I had to do all those, and I had to do it on both sets of ribs. And then, of course, also, because I'm putting lights on the wingtips, I then had to make holes in all the outer ribs to take the wire for the lighting. Now what I did, I burnt the holes through on these, and then just did a clearance with a drill. Saves the wood splitting and stuff like that. So yeah, 36 ribs later, we're ready pretty much to start building the wing. I'm just looking, I've still got the flap one to do as well. Yeah, I might just do the slot in the rib for the flap push rod, and then we'll be ready to build. So I'll come back to you once I've done that slot, and then we'll get building this wing. We won't get far with it today, but at least we might get something laid down. Finally, we have some movement on the wing. Most of the ribs are in. Well, I've done from 18 to 4 at the moment. They're all in there. The main spars there, the top one, bottom one glued in. The small 1/8 ones are glued in. And then I was just comparing this trailing edge, well, they call the trailing edge spar, rear spar, and it's a pretty good fit. So if you were so inclined, what you could actually do is glue some of this 1/8 straight on to the rear spar first of all, before you made the wing. Make that up as a sub-assembly and then just bump, whack it onto the ribs. That would be a really neat way to go, and I'll probably do that actually after seeing this on the second wing. I'll probably assemble it that way rather than putting this rear spar on after. So yeah, it's looking pretty good. There's still a few things I've got to sort out with these ribs 1, 2 and 3. I've got to glue a doubler to them, and I've also got to work out the undercarriage blocks, so that's why I haven't actually put those ribs in. They'll just slide in anyway, not a problem, but it was nice to get this slot glued together, so we're starting to build up a solid structure. So yeah, I'm going to plod on for a little bit longer. Oh god, you can tell it's one of those days. See how far I get. I'll probably just look at the undercarriage blocks. I know I've got God, almost said solder them, sand them to fit, so I'll probably get on with that now. At least they can be dropped in as well, which would be quite nice. And also the ply doublers that go on these ribs for extra strength around the undercarriage area. So I'm going to get on with them, and hopefully we'll get those done before the end of this video. Right, well, I think that's about it for the day. It's 7:30. I've got a couple of ribs there drying off with the extra ply doubler on them. There's one, and there's another one sitting over there with loads of clamps on it. So I'm going to leave them overnight, because I wood glued those. And then yeah, tomorrow we can basically slot them in and see where we are. I've got my piece of undercarriage block mounted there. It's just sitting in there at the moment, but it does fit in all the formers, which is good. So I'll see you all in the next video, hopefully tomorrow, where yeah, I mean, you know, we won't be far off finishing this wing, hopefully. Have to see how it goes. So don't forget, have a look at Sarik Hobbies website if you haven't already. Link in the description. And go and buy something, because without people like them and people like Flight Comp and all the other people that donate, you wouldn't get these videos. So see you all tomorrow. Bye.
Thank you for watching Captain Rob's RC Model Geeks. If you enjoyed the video, don't forget to click that like button. If you want to see more of the same type of videos, don't forget you can subscribe. If you want to support us, you can use PayPal, paypal.me/RC Model Geeks. If you want to contact us, you can email us rcmodelgeeks@gmail.com. We look forward to seeing you in the next video.